In the vast expanse of the cosmos, where the boundaries of possibility are constantly pushed to their limits, mankind has dreamt of a way to break the ultimate barrier, to travel faster than light. For generations, science fiction has tantalized us with visions of warp drives and hyperspeed travel, but it all remained in the realm of imagination. However, in a groundbreaking revelation that will send shockwaves through the cosmos, scientists finally discovered a new way to travel faster than light. This group of brilliant scientists and innovators have unlocked the secrets of interstellar travel that will rewrite the laws of the universe as we know them. Join us in this pioneering endeavor as we unveil how scientists finally discovered a new way to travel faster than light. The quest for swift space travel. In approximately 4.5 billion years, a remarkable celestial event is slated to occur within our Milky Way galaxy. The Andromeda Galaxy is set to collide with our own at great velocity, triggering a series of consequential phenomena. As a result of this cosmic collision, certain stars will be ejected into the far reaches of space, while others will coalesce to form new solar systems. Regrettably, the prevailing consensus is that the majority of life within the combined entity, henceforth referred to as Milko-Media or Milk-Dromeda, will likely face extinction. In anticipation of this unprecedented occurrence, individuals have made the deliberate choice to prepare for the eventuality by embarking on interstellar voyages aboard state-of-the-art spacecraft. The motivation behind such endeavors stems from the fundamental notion that within the boundless expanse of the universe, there exists an infinite array of celestial bodies, potentially hospitable to human life. Crucially, for a planet to sustain human habitation, it must orbit its parent star within a region known as the habitable zone. Within this zone, the temperature must remain conducive to maintaining water in a liquid state, a vital prerequisite for life as we know it. Encouragingly, the scientific community continues to discover star systems that meet these criteria with regularity. One of the most recent findings points to Proxima Centauri, which orbits a red dwarf star and harbors at least 2 exoplanets amenable to human settlement. However, there exists a formidable challenge. Proxima Centauri and its planets are located a staggering 4.2 light-years away from Earth. The vast chasm of space between our planet and this newfound potential haven necessitates the development of spacecraft capable of bridging this immense gap. To meet this exigent need, we must sift through the annals of space exploration and choose a conveyance that can traverse such distances. One option is the Saturn V, a historic rocket renowned for its role in ferrying astronauts to the moon. This formidable machine could attain speeds roughly 30 times faster than the speed of sound. Contemporary advances have introduced more sophisticated technologies, exemplified by the Space 10 Falcon Heavy rocket. Nevertheless, despite these innovations, the speeds achieved by these vessels remain relatively constant. A sobering realization is that, even if propelled by these advanced rockets, the journey to the closest star system would entail a mind-boggling 113,000 years of travel, a prohibitive time frame. Undeterred, scientists and engineers have turned their attention to the swiftest human-made object ever constructed, the Parker Solar Probe. This remarkable probe maintains a velocity slightly below 500,000 miles per hour, leveraging the gravitational influence of the Sun to achieve its remarkable speed. Envisioning a future in which we can harness such velocity, we engage in meticulous star mapping, complex calculations, and detailed diagramming in preparation for the epic odyssey that spans 6,600 years. Cracking the code of light-speed travel. Let's delve into the realm of photon particles, the tiniest entities that zip through space at the speed of light. A natural inquiry arises: how can we construct a vessel capable of matching the velocity of a photon? Until recently, achieving such speeds appeared insurmountable. The bedrock principles of physics assert that any object carrying mass cannot accelerate to such extremes. The energy requisites for propelling mass to the speed of light, approximately 186,000 miles per second, seem infinite. To put this in perspective, gazing at the sun, which seems tantalizingly close, we must acknowledge that its light takes a mere 8 minutes to reach our planet, a time frame comparable to grabbing a quick burger at a drive-thru. Conversely, embarking on a voyage to the nearest star entails a lengthy 4.2-year journey, which could almost see you through a college education. However, recent advances suggest that we may have discovered a potential avenue for circumventing the confines of traditional physics and achieving velocities exceeding that of light. Can we really break the laws of physics? Consider the M drive as an illustrative example, an innovation once hailed as a potential breakthrough for achieving rapid interstellar travel. This technology, having secured patents, operates on a theoretical premise involving the confinement of microwaves within a specially shaped chamber, wherein their repeated reflections generate propulsive forces. Crucially, this chamber remains sealed, giving the external appearance of motion devoid of any external fuel input or visible thrust production. The functioning of the M drive aligns with Newton's second law, which defines force as the change in momentum over time. In this context, electromagnetic waves traveling at the velocity of light carry a certain amount of momentum that imparts upon a reflective surface, thereby yielding a minute but accumulative force. This seemingly straightforward process challenges the foundations of our comprehension of physics. The perplexing aspect of the M drive lies in its apparent lack of energy inflow or outflow. This raises pertinent questions about the initiation of the waves, their sustained movement, and the source of their momentum. The absence of a clear explicatory impetus for this spontaneous momentum generation has led many scientists to dismiss the M drive as a credible concept. The implications of its validity would indeed disrupt a substantial portion of established scientific knowledge concerning the nature of the universe. Notably, efforts were made to test the M drive's claims, with physicists at the Dresden University of Technology conducting experiments. Their findings refuted the promising results initially attributed to NASA and Chinese research, as they concluded that these outcomes were erroneously interpreted due to extraneous factors. Unveiling the Alcubierre warp drive. Warp drive is a technology designed to manipulate the fabric of space and time, effectively bypassing the established laws of motion. In the realm of science fiction, it is often depicted as a protective field or envelope enveloping a spacecraft, allowing it to achieve speeds far surpassing that of light. Presently, we have a theoretical concept akin to this known as the Alcubierre warp drive. In the conventional understanding of spacetime, achieving light-speed travel is deemed unattainable. Therefore, the warp drive operates by distorting space in front of the spacecraft, contracting it, and expanding space behind it. This manipulation results in not only the movement of the spacecraft, but also the space-time continuum within the encompassing field. Practically, this concept allows a spacecraft to reach velocities exceeding the speed of light, potentially even up to 10 times the speed of light. However, it's important to note that to execute this warping of spacetime, the spacecraft must be of colossal proportions and necessitate an energy source on the scale of the entire mass-energy content of a planet the size of Jupiter. The 10% speed of light challenge. In the world of space exploration, scientists have set their sights on a remarkable goal, reaching a staggering 10% of the speed of light. Their target? Sending a probe on an epic journey to Alpha Centauri, a star system located 4.4 light-years away from Earth. To put this into perspective, consider that the famous Voyager 1 mission, launched way back on September 5, 1977, has covered approximately 14 billion miles in the 43 years since its inception. It currently holds the title of the most distant man-made object in existence. Voyager 1 has ventured far beyond the confines of our solar system and continues its solitary odyssey into the great unknown of outer space. Now, the mission to Alpha Centauri will take even longer, an estimated 44 years. But the potential rewards are as vast as the cosmos itself. Imagine the incredible discoveries that await us when the probe finally reaches its destination, far, far beyond our solar system. This interstellar journey represents an audacious leap into the mysteries of the universe, where no human-made object has ventured before. It's a testament to the indomitable spirit of exploration and the insatiable curiosity of humanity. The science of reaching light speed. Scientists are toiling away in their secretive laboratories, brewing up ideas that could transform space exploration. In hushed corridors of the scientific world, whispers have begun to circulate about a tantalizing possibility: reaching the speed of light, the ultimate cosmic velocity. Rumor has it that the Space Association, the pioneers of interstellar travel, is contemplating a daring leap forward. Their audacious plan involves launching compact drones into the cosmos, harnessing the immense power of lasers and even nuclear forces to propel these tiny spacecrafts. The very collision of matter and antimatter, a concept rooted in the famous equation energy equals mass times the speed of light squared, may provide the staggering energy required to reach the elusive speed of light. Imagine humans chasing the light itself. Meanwhile, just a stone's throw away in a nearby laboratory, another group of brilliant minds is diligently toiling on a different technology: ion propulsion. This cutting-edge approach relies on electric fields to accelerate gas particles, creating a method that's as efficient as it is elegant. It's like comparing a reckless daredevil on the road, burning through vast quantities of fuel to reach high speeds, to a careful elderly driver who conservatively presses the gas pedal. In the vast expanse of space, this old lady of propulsion promises to outlast and outdistance the daredevil, efficiently covering remarkable cosmic distances. The truth is that these are innovations of immense magnitude, and it will still take an indeterminate number of years before they are ready for practical implementation. The dream of warp drives, allowing us to bend the fabric of space, and the reality of ion propulsion, a slow but steady journey through the cosmos, both holds promise for the future of space exploration. We shall keep a watchful eye on the horizon, eagerly awaiting the day when these remarkable technologies are finally within our grasp. Until then, the cosmic mysteries of the universe remain a challenge and an inspiration for generations of scientists yet to come. Paving the way to interstellar civilization. Our goal is to make humankind an interstellar species, but there are crucial steps we need to take to ensure our survival. Currently, we're actively working on developing technologies that will allow us to send the first manned mission to Mars. The colonization of Mars represents the initial stage in our journey towards becoming an interstellar civilization. Think of it as a practice run before we embark on missions to even more distant planets. It's important to recognize that while conditions on exoplanets might be somewhat similar to Earth, we can't take them for granted. We'll have to actively transform them, a process known as terraforming. This involves adjusting the planet's environment to make it suitable for human life. On Mars, for instance, we'll need to warm it up to reach a normal Earth-like temperature. We'll also have to increase the atmospheric pressure so that water can exist in a liquid state. Additionally, creating an ozone layer will be crucial to shield us from harmful solar radiation. Once we achieve these goals, humans will be able to breathe freely on the Martian surface without needing spacesuits. Mastering these technologies on Mars is an essential step on our journey to achieving interstellar travel. Only by successfully terraforming and adapting planets like Mars can we hope to one day develop the incredible warp drive technology that will take us beyond our solar system. It's a step-by-step process, and each stage is critical in our quest for interstellar exploration. It's time for today's subscriber pick. Scientists finally discovered a new way to travel faster than light. You see, in recent gatherings of scientists, there has been a growing sense of optimism for the year 2069. The reason behind this newfound hope is NASA's ambitious plan to embark on an interstellar mission. Their goal? To journey beyond our own solar system in search of potentially habitable planets. While the intricate details of this groundbreaking mission remain shrouded in mystery, one thing is clear. It's a tribute to the 100th anniversary of the Apollo mission, the monumental event that saw the first humans step foot on the moon. This upcoming expedition is so cutting-edge that it hasn't even been christened with a name yet. In the heart of Pasadena, California, a dedicated group of scientists from NASA's Jet Propulsion Laboratory are working tirelessly to transform this audacious dream into a reality. Their latest calculations have ignited a sense of triumph and excitement among the scientific community. They've made a remarkable discovery. The shape of the warp field generator surrounding the spacecraft is not a perfect sphere, as previously believed. Rather, it resembles the silhouette of a donut. This revelation promises to simplify the design and construction of the spacecraft significantly, making this ambitious mission more feasible than ever. Perhaps the most astonishing aspect of this endeavor is that they intend to test this groundbreaking technology using a spacecraft similar in size to Voyager 1. Let us know what you think about this breakthrough. The final frontier beckons. Centuries ago, brave sailors took to the seas and honed their vessels to fully uncover the mysteries of our Earth. Now we stand on the precipice of a new era, where we will be the generation to craft innovative spacecraft and embark on extensive journeys beyond our planet. The key to this exciting future lies in the development of warp drive technology. Warp drive is the gateway to a realm of incredible possibilities. When you gaze at the Milky Way, you'll see countless stars, and each of them holds the potential for orbiting planets. Some of these celestial bodies may even support life. Warp drive promises to revolutionize our ability to reach out to this potential life and explore our galaxy at unprecedented speeds. This extraordinary future is no longer a distant dream but a near reality. In the not-so-distant future, the opportunity to become pioneers of the cosmos will be within our grasp. Imagine donning sleek and advanced spacesuits, ready to journey through the vast expanse of the universe in search of thrilling adventures and encounters with the unknown. The astonishing effects of decelerating light. It's worth noting something truly remarkable occurring in the vast expanse of our universe. The speed of light, which acts as our cosmic courier, is gradually slowing down. However, there's no need for immediate concern. This slowdown is happening at such a glacial pace that its effects won't become apparent for another billion years. In the harsh vacuum of space, the speed of light maintains its constant pace, an astounding 186,280 miles per second. If it were any slower, we would witness a spectacular transformation of the universe as we know it. Picture a cosmic kaleidoscope where colors shift, the brightness of objects changes, and even everyday items twist and distort. In their quest to understand the consequences of this transformation, scientists embarked on a virtual journey into this slow-motion cosmos. Although the speed of light remains constant, it encounters various materials and objects, altering the way we perceive our surroundings. Light's mysterious nature reveals itself as both a wave and a particle, a duality that adds complexity. This duality is evident in its wavelength, the distance between crests in the light wave, which defines its colors and frequencies. Light, in a sense, behaves like sound, much like the Doppler effect at play. Imagine standing at the center of a bustling highway with cars whizzing past and horns blaring. As a speeding vehicle approaches, the pitch of the honk appears to change due to the Doppler effect. Light mirrors this phenomenon, where the wavelength changes with its speed. Approaching a light source at high velocity shortens the wavelength, bathing the world in blues and violets. Moving away from the source, a reddish hue envelops your surroundings. If the speed of light were to slow down significantly, we would witness a captivating transformation. Approaching an illuminated object, its colors would shift before your eyes, and the world around you would undergo a chromatic metamorphosis. Walking sideways, the colors you move toward would shimmer with bluish tones, while objects in the distance would take on a reddish tint. For astronomers exploring the cosmos, this insight is invaluable. The phenomenon of blue and red shifting is a cornerstone of their celestial investigations. When an object is blue shifted, it indicates it's moving toward us, while red shift suggests it's moving away. In fact, every celestial object in our expansive universe bears the mark of redshift, a testament to the universe's relentless expansion, drifting farther from our cosmic doorstep. As the speed of light decreases, it has a fascinating consequence: brightness. The light's constituent photons become more pronounced, illuminating the cosmos in heightened brilliance, a dazzling spectacle. While this effect might go unnoticed when you're stationary, the Doppler effect adds a tantalizing dimension. As you approach an object, its colors and light intensities shift, a vivid demonstration of the cosmic interplay of wavelengths and speeds. In this decelerated cosmos, the universe unfolds a stunning array of effects. Colors ripple and change as you venture closer to illuminated objects, while the world itself shifts in a mesmerizing display of chromatic artistry. For astronomers, these alterations in light's behavior are essential tools for unraveling the mysteries of our ever-expanding universe. And as the speed of light slows, it bestows upon us a cosmic fabric painted in ever-intensifying hues, illuminating the boundless wonders of the universe. When time stands still, imagine yourself hurtling through the cosmos at a velocity comparable to the speed of light. In this scenario, a most peculiar transformation unfolds. Time itself begins to behave in a manner quite unlike our everyday experience. The notion that spaces and time are intertwined, where one's motion through space directly affects their journey through time, is rather profound. So, picture yourself at your mundane desk, perhaps engaged in some less than exciting task, while the clock's hands seem to be moving at a frustratingly sluggish pace. You're going through the motions, yet your primary travel is through time, not through space. In this state, you're stationary in the spatial sense, but from a temporal perspective, you're steadily advancing into the future. In essence, you're aging, although it might not feel that way while you're poring over your work. However, here's where it gets intriguing. The more swiftly you traverse through space, the more time appears to stretch. If you could move at the same blistering speed as light itself, a remarkable shift occurs. Your entire journey becomes an odyssey through space, with time itself appearing to slow to a near standstill. To truly grasp this phenomenon, you'd require an observer, another person sharing this cosmic voyage with you. You're not within a time machine. You're both firmly planted on Earth, sharing the same temporal experience. To you, it feels like an exhilarating dash through time because you're covering vast distances in the blink of an eye. But there's a twist. The closer you approach the speed of light, the more relative size becomes a fluid concept. Depending on your vantage point, objects can either appear to shrink or expand. If you're the one rocketing through space at such incredible speeds, an object nearby seems to contract, its size diminishing before your eyes. It's as if the laws of perspective themselves are bending to the whim of your velocity. Yet, to an external observer, someone watching you hurtle at the speed of light, it's as if you too become a miniature version of your true self. Intriguingly, scientists at MIT conducted simulations to delve deeper into this bizarre phenomenon. They revealed that if the speed of light were to suddenly change, the world around you would warp and distort in extraordinary ways. Imagine seeing a mountain range in the distance, and then embarking on a sprint at the speed of light. Those once distant peaks would suddenly stretch further away, an optical illusion defying the laws of nature. Objects, once familiar and stable, now become distorted and elongated, like a funhouse mirror where reality itself warps at your whim. It feels as though you're traversing the universe at an unimaginable pace, but in reality, it's time itself that has chosen to slow its relentless march, all because you're matching the speed of light's dance. To further illustrate this point, let's consider a simple scenario. Assume you're standing completely still, and a companion positioned to your left flings a cube-shaped object to your right. Under ordinary circumstances, you'd perceive only one side of this object in your line of sight, unless it happens to somersault in mid-flight. However, when you're immersed in the reality of near light-speed travel, something mesmerizing occurs. In this extraordinary realm, you witness the object as if it's unfolding before your eyes. What was once the front side of the cube seeming to wrap around, gradually revealing itself to you. This is not mere sleight of hand. It's a consequence of traveling at a velocity so close to that of light itself, where space and time intertwine in a ballet of cosmic proportions. And now, envision a scenario where you're not just moving at the speed of light, but approaching infinity speeds within an infinite expanse of space. Here, the fabric of reality itself becomes a canvas for your imagination to paint upon. Everything, as far as your perception can reach, stretches out into an infinite, dazzling expanse, where the boundaries of time and space blur into an enigmatic fabric of the cosmos. The peculiar world of light and time. In a world where the impossible becomes reality, where humans stride at the speed of light, the ordinary turns extraordinary. This remarkable transformation of our perception challenges the very essence of what we consider normal. Imagine a stroll through a supermarket, a seemingly mundane task turned into an otherworldly experience. As you navigate the aisles, the milk carton at the far end of the counter plays tricks on your eyes and sense of distance. At first glance, it appears tantalizingly close, as if you could reach out and grab it effortlessly. But as you approach, it defies your intuition, retreating into the distance, leaving you bewildered. The strangeness doesn't end there. The milk carton, once seemingly mundane, undergoes a surreal metamorphosis. Its shape shifts before your very eyes, transforming from an inviting white to an unexpected shade of red as you inch closer. And just as you question the mysteries of color transformation, it does something even more baffling. It shifts from red to a cool, serene blue. Every step becomes a journey through a spectrum of colors. In the realm where people move at the pace of light, even turning your head becomes a peculiar endeavor. Your surroundings twist and distort in response to your slightest movement, as if the very fabric of reality warps to accommodate your actions. In this perplexing world, commonplace objects take on new dimensions. A simple shopping cart, pushed by another patron, becomes a complex, three-dimensional model. The cart's colors play a synchronized dance, transitioning with every shift in its proximity. As it moves away from you, it assumes an ethereal quality, seemingly distant yet astonishingly close. It's an optical illusion brought to life, turning the ordinary into the extraordinary. However, this fantastical scenario raises a fascinating point. The speed of light is not as constant as we've been led to believe. In the realm of relativity, where Einstein's groundbreaking theories hold sway, the path of light itself becomes an enigma. Our familiar notion that light travels at a fixed speed of roughly 186,280 miles per second shatters into countless possibilities. Einstein's theory of relativity proposes that the journey of light from source to mirror may defy our intuitions. When light departs its source and embarks on its reflective adventure, its journey may not be as straightforward as we imagine. Perhaps it takes 9 seconds to venture from source to mirror and a mere 1 second to return, or maybe it's the other way around. The paradox of time dilation could lead to entirely different time frames. The implications of this are profound. Our conventional methods of measuring light, based on the principle that the path to the mirror is identical to the path back to the source, become inadequate. The very foundations of our understanding are shaken, forcing us to reevaluate how we perceive the universe and light itself. In this surreal world, the mysteries of light are unveiled before us in a kaleidoscope of perceptions. The concept of time and space warps, leading to an existence where the mundane becomes extraordinary and the ordinary becomes an enigma. It's a world where a trip to the supermarket is an adventure through a landscape of shifting colors and distorted distances. It's a reality where even the fundamental constants of physics are questioned, inviting us to explore the boundaries of what we thought we knew. A world on the brink of darkness. Another scientific breakthrough emerged that defied the very nature of light. Picture a world where the luminous speed of light could be halted in its tracks, preserving its radiance as it came to a standstill. This mind-bending achievement was unlocked through the ingenious utilization of ultra-cold atom clouds, intertwined with photonic crystals, materials intricately adorned with billions of minuscule perforations designed to manipulate and refract light. How about a day when you awaken, expecting the brilliance of the sun's first light, but instead find yourself in a perpetual twilight? As you draw back the curtains, the world outside is bathed in dimness, even though car lights still flicker weakly, casting weird shadows. You fumble with the light switch in your room, but it's as if the bulb is faltering, a faint glow barely illuminating your surroundings. Desperation drives you to swap the bulb, but the new one delivers no better results. You traverse your home, flipping every switch in a futile effort to brighten the dimness that envelops your life. Perplexed, you question if there's an electrical malfunction, but thorough inspections confirm that your home's power supply is in perfect order. You rush to your neighbor's house in the hope of finding solace, only to realize that they, too, are grappling with this perplexing predicament. A shared feeling of helplessness washes over the community as experts and specialists in the field are left bewildered, unable to fathom the mysterious phenomenon that has gripped the world. As the hours slip away, the world remains ensnared in a weird semi-darkness. Everywhere you turn, The light hangs in limbo, a mere shadow of its former self. Your trusty phone, once a beacon of information and connectivity, now struggles to display any meaningful brightness, despite being cranked up to its maximum capacity. Darkness encroaches, and panic starts to spread as the realization dawns. This is a global catastrophe, and the world's luminance is slowly but surely diminishing. News broadcasts recount the disconcerting narrative. Light, the very essence of clarity, is fading, and its inexorable decline threatens to plunge the world into an irrevocable abyss of obscurity. As the hours turn into days and the days into weeks, humanity grapples with a reality where light, once abundant and taken for granted, is now an endangered resource slipping through their grasp. While others around you frantically prepare for the uncertain future, you decide to hold steadfast, to observe this unprecedented phenomenon with a quiet resolve. In this world cloaked in semi-darkness, where uncertainty looms like a heavy fog, you, along with the rest of humanity, stand on the brink of a new era, an era where the most fundamental element of our existence, light, has been inexplicably halted in its journey, leaving everyone to ponder the implications of impending, uncharted darkness. Do you believe that the idea of traveling faster than light is within the realm of scientific possibility? Let us know what you think in the comments below.